Have you ever written an important report, saved it as Project V1, made changes to Project Final, and then eventually exported Project Real Final? It eats up your hard drive, and after a few days of revisions, it becomes nearly impossible to figure out which document actually contains the accurate, up-to-date version of your work. Now, imagine you try to bring a second person into this workflow. What happens when a colleague opens that exact same file on their own machine to add their edits at the same time? This diagram illustrates the classic shared drive trap. Because the system can only hold one current state, whoever clicks Save last instantly crushes and replaces the other person's hard work. Without a system designed to explicitly track and sort out simultaneous edits, the simple act of collaborating actively threatens the integrity of your data. This is the exact problem version control is built to solve. Instead of relying on a standard Save button that blindly overwrites your files, tools like Git act like a meticulous time machine, recording chronological snapshots of every single change you make. Git is simply the software engine installed directly on your local computer. It strictly tracks your files while you work offline. This diagram shows how it connects to the broader world. On the left is Git, your local workspace. On the right, via the internet, is GitHub, a remote hub in the cloud where those local changes are stored, backed up, and synchronized. If we zoom into the local side, the process starts in your working files. These are the raw daily edits you make, like typing a new paragraph or deleting a line of code. From there, you move to the staging area. Think of this like a packing zone. You deliberately select exactly which of those raw edits you want to bundle together for your next snapshot. Finally, you commit. This action takes the items in your staging area, attaches a short descriptive label, and locks them into a permanent snapshot on a linear timeline. By forcing you to pack and label your edits through this three-zone local model, the system completely prevents accidental destructive saves. But how do we safely move those local snapshots up to the cloud? This diagram illustrates the concept of a branch. It creates a safe, parallel universe that splits off from the main timeline, allowing you to experiment and build freely without touching the core project. When your local snapshot is ready, you initiate a push. This sends your finalized bundle of changes up to that parallel track on GitHub. Once your code is in the cloud, you open a pull request. This acts as a formal invitation, asking your teammates to review, discuss, and approve your proposed changes before they become official. After passing review, the changes undergo a merge. The parallel track reconnects with the main timeline, smoothly blending the approved work back into the core project. To keep this cycle running smoothly, version control relies on a golden rule: always pull, or download, the latest remote version from GitHub to your computer before you try to push any new work up. If two people edit the exact same line of code at the exact same time, the software doesn't try to guess who is right. It creates a merge conflict, freezing the process and actively highlighting the contradictory lines so a human can manually decide which version to keep. By combining isolated branches with a formal review process, this pipeline stops collaboration from being a destructive race to overwrite files. It turns the workflow into a carefully curated, peer-reviewed conversation. This image reveals a stark contrast to the chaotic desktop from earlier. You are left with a single, pristine master folder. No duplicates, no guessing. Beneath that clean surface, the entire history of the project is perfectly preserved. Every addition, deletion, and edit is fully searchable and instantly reversible. Knowing that your previous states are secure removes the anxiety of accidentally ruining a project. You have the freedom to try bold ideas because you can always jump back to a working state. This visualization shows how the architecture rapidly scales as a project grows. What starts as a solo endeavor can seamlessly expand to coordinate thousands of contributors working at the exact same time all across the globe. This architecture serves as the foundation for modern digital creation, providing the structure that allows thousands of people to build complex systems together without losing a single line of work.